Hi again, and this is our last lesson of the year. I have to confess, I didn't think this is the way that I was going to say goodbye to you for the year, but this is probably the last you're going to hear from me and see me this year until September. And even then, who knows what it's going to look like when school starts up again. So, not quite what we thought this spring was going to be like. And, for those of you, your first year of high school, it's probably not exactly how you saw this year going. But be that as it may, we're here and we've reached the end of Algebra 1. So let me give you an idea of what the next couple of weeks are going to look like. This is the last lesson. And we'll wrap up this whole unit that we've been talking about with just some different concepts surrounding functions. Next week is going to be a full-blown chapter test. And that's going to be it. That's how we're going to wrap things up. But that'll be your task for next week. So great chance to finish strong. Give yourself a little grade boost at the very end. Also, I want to talk to you a little bit about grades. If you recall, when we first left, we had this plan in place. We had all worked out, and then the state said, no, you're going to do it this way instead. So you're going to get one of two grades at the end of school this year. First of all, third quarter grade by itself doesn't mean anything. But what matters is your semester grade. And those of you in 9th or 10th grade, obviously this is part of your ongoing high school transcript. 8th graders, you're in the same boat though. This is still going to be part of your high school transcript, but we may have to talk a little bit about what some of your options are moving forward, especially in light of what this spring has been like. So what you're going to do is you're going to get one of two options. Either you'll get the better of your current grade or the grade you had when we left in March. So if your grade's gone up since then, because you've been working hard and turning things in, you'll get that higher grade. If your grade's gone down since then, based on the work you've done, you'll still get the grade you had when you left, which might be kind of nice. Either you get that, or you'll get an incomplete. And I understand that some of you just, for whatever reason, haven't been able to engage and take part in learning this spring, and so you'll do it next fall instead. The current plan is that when we have half days next fall, everybody else will go home, and those of you with incompletes will stick around and do your math or do your English or do your science, whatever classes you need to finish up to clear that incomplete. So the incomplete will just be a holding pattern. It won't be permanent on your transcript. But then you'll have a chance in the fall to make up this work you weren't able to do this spring. So that will go in when school ends in a couple of weeks. At some point, I need to get books back from all of you. I don't know how we're going to do that yet. I've talked to the school, and the problem is we're not in a situation where we can just have like a big book drop-off event, because you can't really be on campus. School's closed, and we still can't gather yet. So we're going to figure out some way to get your books back, but keep your books handy. Make sure that they're ready to go, because when I tell you, hey, this is the plan, I want to make sure that you get them. And we'll talk a little bit more details about how I make sure that I know it's your book when you turn it in. The last thing that I want to mention, and this is a little bit tricky for all of you, is schedules for next year. I think a lot of you 9th graders probably didn't get to choose too much of your schedule because you're locked into certain courses, but then you had a couple electives you get to pick. 8th graders, you're not going to get many choices at all because you're going into 9th grade. But we will have to talk a little bit about some of your math options as well. So I don't know exactly how scheduling is going to work. What I think is going to happen is, your basic courses, your 9th grade English, your 10th grade English, your math courses, I know where most of you are going to probably end up. even with the incompletes. Maybe a science course or a history course. Those sorts of courses that are kind of grade level based and are already predetermined, those will probably be scheduled automatically for you. And then I don't know how she's going to do it, but Mrs. Tennis is going to have some plan in mind for letting you pick your electives, and maybe let you take a look at your at the overall master schedule, and then you can pick which classes you want to fill in. I don't know exactly how it's going to go, but normally at this point we probably would have this done, and you would have had, you know, obviously conversations with me about math, but would have had conversations with Mrs. Tennis as well, or in your advisories to figure out what your class was going to look like. So yeah, it's a little bit different and weird, and that's just kind of the world we're in right now, but we'll make it work, don't worry. We'll make sure you got a schedule for next year. Have a chance to take the courses you want to take. Okay, so we're going to wrap up this whole unit on sort of special topics and functions. And I want to do it sort of an interesting phrasing of things. Like whenever we work with functions, normally we plug a number in, like we did last week. Like you plugged a number in, this is the bakers and the cupcakes and the decorators and so on. You plug something in, you do something to it, and you spit it out. That's what a function does. It does things. It's a doing function. Well, I'm going to talk about what happens when we undo or go in the reverse direction. But instead of reverse, I'm going to use a different word called an inverse. Okay, so instead of a reverse, it's going to be an inverse. And ultimately what this comes down to is really a matter of, you know, we usually take X, plug it in, and we get Y. Well, this time we're going to take Y, plug it in, and get X, basically. So it's going to involve switching direction and switching the roles of X and Y. So let me show you real quick what this might look like. Let me take a function f of X equals 2X plus 3. Okay? What I'm going to do is I'm going to make a little XY chart. I'm going to do it this way just because I got a little bit more room to do this way. We'll go 0, 1, 2. This is like the T chart we used to make to graph linear function. So let's just figure this out. If X is 0, then f of 0 is going to be 2 times 0 plus 3. If X is 1, 2 times 1 is 2. And if I add 3, I get 5. And then 2 times 2 makes 4. 4 plus 3 makes 7. 3 times 2 is 6. 6 plus 3 makes 9. And 4 times 2 is 8. 8 plus 3 is 9. Okay? So we have these pairs now. 0, 3, 1, 5, 2, 7, 3, 9, and 4, 11. So what would it look like for the, to do the inverse, to do the reverse, or to swap this? Well, we would simply swap the X and the Y. So I'm going to write X and Y here, but where the X's were 0, 1, 2, 3, 4, now the Y's will be 0, 1, 2, 3, 4. And where the Y's were 3, 5, 7, 9, 11, now the X's are 3, 5, 7, 9, 11. So we just simply swap the X's and the Y's. So we'd have this 0.30, 5, 1, 7, 2, 9, 3, 7, 4. So that's pretty easy right there, just swapping the positions of X and Y. That's not really that difficult. That's not quite exactly what we're going to do, but that's the concept we're going to get at. And it turns out that these two, they're both functions in this case, actually have a graphical relationship that's kind of interesting. We'll get to that in just a few minutes before we get done here. But what I want to do is I want to show you a process we can go through, an algebraic process that will take us from a function like this to its inverse. Okay? So let's move on and let's look at this. We're going to start with f of x equals 2x plus 3. But for this to work, I want to back off this idea of using f of x and really want you to think of this as y equals 2x plus 3. That's really what we did, is we plug in x's and then we solve for y's. Okay, so now here comes the big step. The first step is we swap x with y. That's it. So where I have y equals, now I have x equals. Where I had 2x, now I have 2y. So swapping x and y gets me that. Okay, great, I mean, that looks nice, but the problem here is if I want the inverse, I'm in the process of making here, to be a function, I've got to get it eventually into y equals format. So the second step is solve for y. And this takes us back, guys, to like way at the beginning of the year, where we had these formulas, and I said, okay, solve for r, for example. And we had to peel away all the stuff that wasn't r, or whatever the variable was, and we had to solve for it. So watch. If I want to solve for y here, the first thing I'm going to do is peel off that 3. Those go away. I'm going to rewrite it in different form here. 2y equals, this is x minus 3. And now I continue peeling off things that are not y. I divide by 2, divide by 2. And y equals either x minus 3 all divided by 2, or I could write it as 1/2 times x minus 3. And you might notice this as being more like a point slope form. I don't know if that helps at all, but it looks a little bit like point slope. So that's what we do it. So we swap x with y, and then we solve for y. That's the process. Now I want to go back and check here real quick. As we have y equals 1/2 x minus 3. Let's go back here and say y equals 1/2. A big question mark here. The question is, do these values here support that function there? So let's start. Let's say x equals 3. 3 minus 3, let me go here. 3 minus 3 is 0, and 1/2 of 0 is 0. Okay, what if x is 5? 5 minus 3 is 2. 1/2 of 2 is 1. What about 7? 7 minus 3 is 4. 1/2 of 4 is 2. Interesting. So on this page, we could certainly swap the x and the y, that's fine, but we had to have the points to be able to swap them. Now, with this process we have of creating the inverse function, we can create all the points that we want. Now, there's a little bit of an interesting notation here. And I want to go back to this right here. If this is my original function, there's a special way we write the inverse. And it's going to look a little bit like something else, but it's not that. If that's the function, f of x equals 2x minus 3, what I do is I write f to the minus 1 of x equals 1/2 times x minus 3. So what is this saying here? Well, this notation right here, does not mean, it's not a negative exponent. It's not like you're going to create a fraction or flip it to the bottom. Remember, we did all the work with our exponents earlier too. This is a specific notation. I'll erase this in a second, but this notation right here means inverse. Well, I'll just leave it up there. So that notation after the -1 means inverse. Okay, so I'm gonna let you try one now. And let's see if you have some fun with this. I'm gonna give you a function, f of x equals 3x minus 1. And I would like you to find f of -1, the inverse of function f. So I'll remind you what the steps are. Then I'm gonna let you pause the video, try this on paper, then you can come back and see how you did. Okay? So the two things I'm gonna remind you are that the steps involve swapping x with y and then solving for y. Okay? Swap x with y and then solve for y. So at this point, I'm gonna let you pause the video, work this out on your own, and then let's come back together and see what you think. Okay, so the first thing we're going to do is we're going to replace the f of x with y. So we have to have an x and a y to be able to swap in the first place. So now we swap, and I get x equals 3y minus 1. Okay, that part should be easy. You're just literally moving the x's and y's in different places. Now, solving for y can be a little bit tricky. So let's go through this very carefully. This is what I want right here. So the first thing I'm going to do is try to get rid of stuff I don't want. Start with the ones. So now I'm going to have 3y equals x plus 1. Now, if you're wondering, could I have written this x plus 1 equals 3y? Of course I could. But remember, I'm trying to get this to look like y equals. So at some point when it becomes a little bit easier, I tend to look at it from the other direction so that I get y a little bit more by itself, because now I divide by 3, and I get y equals, and again, there's two different ways to write this. X plus 1 over 3 is fine, or you can write it a little bit more common way, 3x plus 1. So I go up here now and I write f minus 1 of x is 1/3 times x plus 1. And that's my function. So that's it. Swap, solve. Not bad, right? Okay, so if that's okay, then I want to take you a little bit deeper. Actually, if it's not okay, I'm still going to take you deeper. And have you look at one very special function whose inverse you already know. In fact, you've done it in this unit and you didn't realize it. That function is f of x is x squared. So let's go through the process and look at this inverse function. I'm going to write y equals x squared. Remember the first step now? Swap. X equals y squared. And just to be a little bit cleaner, I'm going to switch it right now to make it y squared equals x. Okay? All right. So now, how do you solve this? Well, you should remember, take the square root of both sides. We get y equals, the square root of x. Remember that? That's the one you worked with at the start of this unit. So that's great. So f, the inverse of x, the square root of x. X squared does something. The square root undoes that something. Does that make sense? With x squared, we do. With the square root of x, we undo. But there's a bit of a problem here. And the problem comes, it's something you should know, that when you solve an equation by taking a square root, you don't just get one, do you? You get plus and minus. You get two. And what does plus square root of x look like? And what does minus square root of x look like? Well, I'm so glad I asked because I'm going to show you now. Okay, this is what it looks like. You notice that the top half is y equals plus square root of x. That's the function that we graphed a couple weeks ago. See, there's a point at 0, 0, there's 1, 1, 4, 2, 9, 3. Great. What I didn't show you a couple weeks ago, but some of you kind of figured out, is that if I had minus the square root of x, it just means all the y coordinates are negative. So we're going to have 1, negative 1, 4, negative 2, and 9, negative 3. And these two together, if you look sideways at it, kind of looks like a parabola, doesn't it? But there's a problem. Who knows the problem? That's a rhetorical question because you can't answer it. I mean, you can answer it, but I can't hear you. The problem with this is the vertical line test. As in, this is going to fail the vertical line test because there's lots of places I can draw a vertical line and it's going to cross the graph twice. So we don't get this. We don't get to use this. We only get half of this, which means we get this. And this is the square root function that we talked about. We didn't have the bottom part because it's not part of the actual function. It would not be a function that way. So it turns out that the answer truly is just the square root of x, and we just get a limited portion. Basically, we get half of our original graph, and that's the inverse. Now, when you get into Algebra 2, we'll talk a whole lot more about how we make a parabola, which has two halves to it, sort of flip on its side and become just one part. That's something we'll deal with down the road. But for now, I just want you to understand that not every function can be automatically inverted, because sometimes when you invert a function, you create something that's not a function. All right, let's go back to the whiteboard. And I want to show you a couple things here real quick before we shut down. So remember I had this function before. I had f of x equals 2x plus 3. And we figured out together that the inverse of that is f minus 1 of x is 1/2 times x. We check that out. Now, what I want to show you, I'm going to switch over to decimals here in a second. I'm going to show you graphically how these two functions relate to each other. This is kind of surprising, and frankly, I think it's kind of cool. Let me go back here. We're going to be at decimals now. I'm going to graph y equals, so I have to do it this way, but y equals 2x plus 3. Okay? We've seen that before, right? And then I'm going to graph y equals 1/2, whoops, no way. 1/2 parentheses x minus 3. What I want you to see here is that these two lines kind of look like they mirror each other, yeah? I mean, they intersect down at this point down here, which is fine, but they kind of look like mirror images of each other. But the question is, what line serves as the mirror? Well, I will tell you. It's y equals x. Look. Look! Y equals x splits it right in the middle. Guys, this is a massive, massive thing. Every function and its inverse are always mirror images of one another across the line y equals x. And why is it y equals x? Because we swap y and x. We let y be x and x be y. That's what you get when you swap these. So we're about to wrap up, but I want to show you the x squared part here. So let me clear this out for you real quick. I just think this is super cool. So bear with me if you don't agree, but I think it's cool. Y equals x, x squared, and y equals the square root of x. Now, obviously, this is a little bit weird because it's only half of the graph, right? So let me first of all do y equals negative square root x. And I want you to see that if this was legal, that the sideways parabola, it looks like it's just a perfect sort of mirror of the vertical parabola. And here's a point, -2, 4. See that point right there? -2, 4. Well, what if you swap? It would go 4, -2, right? What's right here? 4, -2 is right there. Yeah. So this works. Now the problem is, that's what it really comes down to, which means we're kind of limited. Like we can't actually invert this second part of it. That's advanced algebra stuff. But I wanted you to see, why I'm gonna leave it up here because I think it's kind of cool how those two graphs fit together. Okay, quick summary of what we've done, and we will call it a year. Wow. Step 1, swap x and y. Step 2, solve for y. And then a couple other thoughts to keep in. We'll call this thought A. Some inverses aren't functions. I'll do y equals x squared. Now y equals x squared is a function, but if you purely invert it on its side, you'll see it's not a function. And the other comment here is the graph of a function and its inverse are always mirrored. It's a weird word, mirrored reflections across the line y equals x. Okay. So technique, swap x and y and solve for y. Thoughts, some inverses aren't functions, and the graph of a function, its inverse, will always be mirrored reflections across the line y equals x. All right, so they'll have that in the slides I give you. So this is it, guys. This is your last assignment of the year before our test next week. Option number 1, page 454, 5 through 8, 23 through 28. Okay, that's out of your book. The last, and I'll probably have a review assignment out of your book, but that'll be the last assignment. Option 2 will be a worksheet, inverse of function. This is just the name of the worksheet, but you'll see it on the web page as that. And we'll just do questions 1 through 8. And then option 3 will be inverses of linear functions. And this will be 1 through 19, just the odds. So they're basically the same number of problems. One's maybe a little bit higher than the other, but they're all about the same number of problems. So as the last couple of weeks, pick one of these, do it, send it to me, and I'll check you off for the week. And then next week, I'll have a review assignment for you. Remember that one of the sections, one of the last sections we did, Oh, the last section, yeah, the composition of functions was not in your book. So I'll have to give you some extra practice problems, or I'll just point you to maybe one of the worksheets to go do some more review on that. And then your test will be the week of June 8th to June 12th. Test due by June 12th. That's all she wrote. It'll be summertime, and it's going to be looking a lot like it does now, except for a little bit hotter. So be good, you all. Be well. Be nice to your family. Take care. I'll see you when I see you. Bye.